Picture yourself landing on Mars, a place that looks utterly inhospitable at first sight, with vast stretches of nothingness that seem utterly unfit for human life. From the get-go, Mars might strike you as a rather unwelcoming, even harsh environment, missing almost all essentials required for sustaining life. This scenario paints a rather grim image, suggesting that the most we could aim for is to dispatch small groups of adventurers to survive in bleak conditions, tucked away in underground hideouts. But what if there's a possibility to turn this red barren land into a lush, vibrant world brimming with life? This idea isn't mere fantasy or a snippet from a sci-fi novel too good to be true, it's an actual possibility. The notion of terraforming Mars, transforming its hostile environment to resemble Earth's, is realistically achievable within a time frame akin to the monumental eras, during which our forebears constructed their most magnificent achievements. Should humanity overcome its present hurdles and extend its reach into outer space, remaking Mars stands as a potentially groundbreaking feat in our interstellar saga. Here's where it gets really captivating. To make Mars suitable for human life, we might need to take the planet through extreme transformations. Among the more startling proposals is the idea of blanketing Mars with seas of lava, using massive lasers for the job. That's correct, envisioning Mars as a fiery realm as a preliminary step toward cultivating a verdant, habitable planet. So, where do we start with such a colossal undertaking? Swiftly terraforming Mars is undoubtedly a complex challenge, teeming with hurdles that test the bounds of our existing tech and scientific savvy. Nevertheless, this endeavor opens up a world of intriguing possibilities, clever solutions, and the chance to realize a future in which humanity's home extends beyond the confines of our current terrestrial boundaries. This story of remaking Mars encourages us to think big, to reflect on our role in the universe, and to strive for a future where the red planet bursts into life. As we gaze into this far-off vision, let's delve into the steps, the science, and the tactics that could morph this fantastical vision into reality. So, strap in. We're on the verge of a remarkable journey to transform a planet, testing the limits of the imaginable, and in doing so, possibly reshaping our understanding of humanity itself. Mars, with its dry terrain and absence of rich soil, might not seem like the ideal spot for humanity's next chapter. Its thin atmosphere provides little protection against the harsh space radiation, significantly heightening the cancer risk for potential inhabitants. Yet, consider the potential to turn this barren land into a sanctuary for human life, equipped with a breathable atmosphere, flowing rivers, and expansive oceans. For this vision to come to life, we must aim for an atmosphere similar to Earth's, containing 21% oxygen, 79% nitrogen, and a slight mix of CO2, with an average temperature of 14 degrees Celsius and a stable pressure of about 1 bar. Creating water bodies and altering the Martian soil from lifeless regolith to fertile Earth capable of supporting life are fundamental steps in this ambitious journey. Moreover, nurturing a vibrant biosphere and putting in place enduring defenses against the dangers of space are imperative to make this new habitat sustainable. Though the undertaking seems immense, the smart use of cutting-edge technology, like high-powered lasers, could significantly streamline the process. The quest begins with the revival of the Martian atmosphere. For billion years back, Mars was shrouded in a thick, oxygen-rich atmosphere, hosting vast bodies of water and flowing rivers. This early Mars clung to its life-supporting air for hundreds of millions of years before it was gradually stripped away. The constant assault of ultraviolet radiation slowly broke down the atmospheric gases, diminishing the planet's capability to retain water, resulting in the Mars we observe today. Bringing Mars back to its former state is more than just a technological challenge, it requires a leap of imagination. It's about reigniting the planet's long-lost rivers and oceans, revitalizing its soil, and protecting this reborn world from the same cosmic forces that once made it desolate. This mission is not solely about survival but about thriving in new territories, about our unyielding drive for exploration, and the persistent dream of extending our domain beyond our own planet. The path to transforming Mars is strewn with challenges that have no precedent, each demanding solutions as creative and bold as the mission itself. From reconstructing the atmosphere to reshaping the terrain and establishing a self-sustaining biosphere, every phase of this journey celebrates human creativity and our relentless desire to reach out and make a home in the cosmos. This venture transcends science fiction, offering a peek into a future where humanity embarks on its grand journey to become a species that inhabits more than one planet. Carried away by the relentless solar wind, Mars stands as a stark reminder of nature's indomitable power, presenting a landscape that seems almost defiant to those who dream of making it their new home. However, beneath its unwelcoming exterior, there's a spark of promise. Hidden within Mars's crust and at its poles are substantial reserves of water ice, poised to potentially fill future Martian seas. Additionally, the planet's very soil holds vast amounts of oxygen, trapped in the iron oxides that give Mars its characteristic reddish color, as well as carbon dioxide encased in carbonate minerals. To access these essential resources, we're tasked with reversing the natural processes that have locked them away for eons. The method? Thermolysis, which requires temperatures as extreme as those found on the Sun's fiery surface, essentially melting Mars's surface to release these trapped gases. This bold strategy suggests the use of powerful lasers from orbit to spark this monumental change. While the undertaking is formidable, it's within the reach of human capability. Take, for example, the ELINP project, which has mastered the art of generating 10 petawatts of laser power, even if just for a moment. The task at hand calls for a laser with double this power operating continuously. The key to this puzzle? A solar-powered laser, cleverly utilizing the sun's endless energy supply. This strategy signifies the merging of our peak technological achievements with our most daring aspirations for the future. By tapping into the solar power to fuel these unparalleled lasers, we're setting the stage for thermolysis on a planetary level. This ambitious operation aims not only to release the gases vital for crafting a breathable Martian atmosphere, but also to initiate the formation of water bodies, paving the way for a Mars that can support life. Turning Mars from a stark, lifeless desert into a thriving, habitable planet narrates a story of human aspiration, inventive spirit, and technical mastery. It embodies a vision of humanity stretching beyond its earthly confines, using innovation to rejuvenate and inhabit the cosmos. As we approach such transformative possibilities, it's a testament to the unlimited potential that lies ahead in our journey toward becoming a species that inhabits multiple planets. Swept by the solar wind into its current state, Mars presents as a barren, inhospitable expanse. Yet, underneath this harsh exterior, there's a spark of potential. Vast amounts of water ice hidden in its crust and at the poles. Unleashing this ice could create sprawling, shallow seas, infusing life into Mars's barren landscape. Additionally, the planet's rocks are rich in oxygen, tied up in the iron oxides that give Mars its characteristic red color, along with carbon dioxide locked in carbonates. Our bold plan involves reversing the natural processes that trap these gases using thermolysis. requiring extreme temperatures akin to those on the Sun's surface, to essentially melt Mars's surface and free these crucial elements. The linchpin for this vast planetary makeover is the strategic deployment of lasers in orbit aimed with precision at Mars. The most formidable laser we possess today can generate a 10 petawatt pulse for a brief trillionth of a second. Yet, the task at hand demands a laser with double that power and, crucially, one that can maintain its output continuously. Enter the solar-powered laser, a brilliant innovation fueled by the direct energy of the sun, ready to take center stage in this endeavor. This system relies on glass rods infused with metal to capture solar energy and transform it into a powerful laser beam. Imagine constructing a massive constellation of mirrors in space, covering an expanse over 11 times the size of the United States, all focused on channeling enough sunlight to begin the melting process of Mars's crust. The activation of this colossal laser array is expected to release approximately 750 kilograms of oxygen and carbon dioxide from every cubic meter of Martian rocket altars. Our aim is to delve about 8 meters deep into the crust to free an ample amount of oxygen for the planet's future atmosphere. The scene would be nothing short of breathtaking. Martian skies, once clear, would brood with stormy clouds, and the surface would radiate with an eerie red glow, marked by streams of flowing lava, all under the relentless gaze of our orbiting lasers. These beams, too intense for direct observation, would leave in their wake a quickly cooling terrain. An unusual kind of snow, made not of water but of ash containing silicon and iron, would dust the ground, solidifying as the temperature drops. Amidst this tumultuous transformation, Mars would still be a cold planet. However, a serendipitous side effect of our efforts would be the release of water previously locked in polar ice caps and subterranean reserves, rising as steam into the Martian air. This vapor would form clouds, which would then precipitate, showering the newly scorched land. This celestial downpour would not only soothe the heated landscape but also purify the air, removing volatile compounds like chlorine and other deleterious substances accumulated on the Martian surface. This radical transformation, although fraught with upheaval, sets the stage for a Mars that might someday nurture life. The scale of the challenge is monumental, the ambition daring, and the potential impact of such an endeavor could resonate for generations, heralding a significant milestone in our pursuit to inhabit multiple planets. As we begin to mold Mars, the emergence of shallow, albeit saltier, oceans signifies the first steps toward a reimagined world. Yet, the creation of these water bodies represents just the beginning. To ensure these embryonic seas evolve into habitats suitable for future life forms, further purification efforts may be required. This process, estimated to take around 50 years of relentless laser operation, goes beyond merely crafting an atmosphere. It's a chance to intricately shape the Martian terrain. By sculpting basins for these briny waters and rivers, while carefully preserving iconic landmarks such as Olympus Mons and Valles Marineris, we maintain Mars's distinct geological identity as we endeavor to render it more akin to Earth. However, establishing an atmosphere rich in oxygen is merely one piece of the puzzle. The resulting atmospheric composition, dominated by oxygen at a mere 0.2 bar pressure, poses unique challenges for human habitation and significantly increases fire hazards. Addressing this issue and moving towards conditions more reminiscent of Earth's necessitates a considerable influx of nitrogen, a resource Mars sorely lacks. This calls for a bold plan to import nitrogen from Titan, Saturn's largest moon, enveloped in a nitrogen-heavy atmosphere. Shifting 3,000 trillion tons of nitrogen from the outer solar system to Mars might sound like an insurmountable feat, yet it's within the scope of human capability. The execution of this massive operation would necessitate the construction of enormous automated processing plants on Titan, energized by the same groundbreaking laser technology. These installations would be dedicated to capturing Titan's nitrogen-abundant atmosphere, condensing it into liquid form for the journey to Mars. Despite its complexity, this initiative exemplifies the heights of human creativity and our unwavering commitment to turn the seemingly impossible into reality. Turning Mars from a stark and inhospitable expanse into a thriving, habitable realm is a story of profound aspiration and unmatched technological ingenuity. Through persistent application of laser technology, meticulous engineering, and the strategic relocation of vital resources, we edge closer to envisioning Mars as a potential new dwelling for humanity. This odyssey, laden with hurdles and necessitating an extensive, concerted effort spanning decades or even centuries, captures the essence of human exploratory spirit and the immense potential of collective endeavor in our venture among the stars. Once this nitrogen is harvested and liquefied on Titan, it would be stored in robust, bullet-shaped containers, engineered for both durability and efficiency to withstand the journey across the cosmos to Mars. As these containers enter the Martian atmosphere, they are programmed to disperse their payload in a controlled explosion, blending the nitrogen with the pre-existing oxygen, thus gradually infusing the Martian air with the critical nitrogen needed to render it akin to that of Earth. Navigating the logistical challenges of transporting such colossal amounts of nitrogen from Titan to Mars presents a monumental challenge, but one that is surmountable with advances in space travel technology and the appropriate allocation of resources. Anticipating completion within a few generations, this project presumes ongoing advancements and dedication in the realm of space exploration and technological development. Ambitious, certainly, but entirely within the realm of what human creativity and resolve can achieve. The task of transforming Mars could have been streamlined if we had access to nitrogen reserves, potentially available from Venus's terraforming, an intriguing concept we've delved into before. This idea of interplanetary resource sharing highlights the innovative strategies we could employ to make multiple celestial bodies more welcoming for human life. A century into the terraforming effort, Mars might present a breathable atmosphere, achieving an ideal mix of gases. If the released CO2 proves insufficient for warming the planet to comfortable levels, we could deploy super greenhouse gases to quicken the temperature rise. Such efforts would see Mars shedding its image as a desolate void, evolving into a black marble, speckled with burgeoning oceans and remnants of its red, volcanic past peeking through the cooling magma. However, even with an amenable atmosphere and emerging aquatic landscapes, Mars would still resemble an earthly desert absent of life. This leads us to the formidable task of establishing a biosphere. Cultivating a biosphere from the ground up on a new planet is laden with challenges. Introducing life, starting with basic microorganisms and scaling up in complexity, demands meticulous planning to anticipate and manage the ecological dynamics. Navigating the risks of unforeseen species interactions, the emergence of diseases, and the threat of ecosystem collapse requires a careful, deliberate approach. The journey to foster life on Mars might begin with introducing microorganisms tailored to thrive in its unique marine environments. These initial life forms would lay the foundation for a more intricate ecosystem, initiating the transformation of Mars from a barren landscape into a world brimming with life. This delicate first step signifies the dawn of a vibrant, life-supporting Mars, opening a new chapter in our endeavor to inhabit multiple planets. Introducing phytoplankton into the Martian waters marks the commencement of building a rich aquatic ecosystem. In the absence of predators, these tiny photosynthetic organisms would flourish, creating the bedrock of a burgeoning food chain. This bloom of phytoplankton would attract zooplankton, which, in feeding on them, sets the stage for the arrival of more complex marine life, such as fish and potentially even larger creatures like sharks and whales in a hopeful future. Achieving this would mean the establishment of flourishing marine ecosystems in Mars's waters, a critical step toward a planet capable of sustaining itself. When we shift our focus to the Martian surface, the task becomes more daunting. The planet's terrain, largely a mix of hardened lava and ash, is not naturally conducive to plant life. The transformation of such material into fertile soil through natural weathering would ordinarily span millennia. Yet, given our ambition to hasten Mars's rebirth and the advanced technology at our disposal, we're not inclined to wait that long. This is where our versatile laser technology comes into play once more, offering a swift solution to prepare the ground for terrestrial life. By strategically applying the laser, rapidly toggling it on and off, we can swiftly heat and cool the Martian surface material. This action, mirroring an advanced form of weathering, breaks down the solidified lava and ash into finer pieces, speeding up soil creation. This innovative approach efficiently converts barren Martian ground into fertile land, ready for agriculture and plant life. With the foundation set for both aquatic and terrestrial biomes, we move to introduce vegetation on Mars. Beginning with resilient pioneer species that can endure tough conditions and enrich the soil with organic matter, we gradually progress to a richer variety of ecosystems. These first plants do more than just foster soil development, they kickstart the production of oxygen through photosynthesis, enhancing and stabilizing the Martian atmosphere. This stepwise process, from seeding the oceans with microorganisms to establishing complex land ecosystems, illustrates the detailed and thoughtful approach necessary for bringing life to Mars. Every phase, underpinned by meticulous planning and technological innovation, edges us closer to a Mars vibrant with life, reshaping a once desolate planet into one reminiscent of Earth. These endeavors not only broaden the scope of human potential, but also represent a crucial stride toward a future where humanity thrives across multiple planets. Introducing water to the newly processed Martian ground results in nutrient-rich mud, a perfect medium for life. We then add fungi and nitrogen-fixing bacteria, unsung terraforming champions that capture atmospheric nitrogen to produce plant-sustaining nitrates. This step recreates Earth's natural symbiotic relationships, establishing the basis for a complex and thriving Martian biosphere. The pioneering plants selected for Mars are chosen for their robustness and proven success in Earth's volcanic terrains, closely mirroring the conditions we've engineered on Mars with our laser technology. Their introduction signals the start of Mars's greening, as these hardy species kick off soil formation and stabilization, laying the groundwork for a richer variety of ecosystems to emerge. As this soil becomes more fertile and complex, it prepares Mars for the emergence of grasslands and forests. The planet's reduced gravity offers a unique benefit, allowing trees to grow taller and more rapidly than their Earth counterparts, their roots penetrating deeply to break down the rocky substrate into nutrient-dense soil. This enhancement of the soil's fertility is key to cultivating a self-sustaining ecosystem, marking a significant achievement in Mars's terraforming process. With the foundation for a balanced ecosystem established, we can start introducing a broader spectrum of flora and fauna to Mars, humorously excluding mosquitoes. Yet, the introduction of life on Mars necessitates vigilant management to ensure the stability of this burgeoning ecosystem. Factors such as unchecked plant growth or the disappearance of crucial species could unbalance atmospheric gas levels, potentially cooling the planet excessively or precipitating rapid ecological declines that the young Martian biosphere may not withstand. Mars's isolation poses additional challenges, lacking Earth's capacity for naturally correcting ecological imbalances through species migration, underscoring the need for careful oversight in this extraterrestrial environment. Transforming Mars into a stable habitat capable of hosting extensive human settlements might span centuries or even millennia. Envisioning Mars adorned with breathable air, abundant water, and thriving ecosystems paints a picture of a planet reborn as a colossal volcanic island adrift in the cosmic sea. Its landscape, dark with volcanic residue, interwoven with the blue of nascent seas and the green of emerging life, stands as a vibrant testament to human aspiration and creativity. However, the enduring success of such a transformation raises critical questions about sustainability. Can this carefully constructed and meticulously maintained world withstand the tests and tumults of time? The future of this endeavor hinges on our ongoing dedication to nurturing and preserving the delicate balance of Martian ecosystems. As we venture into the new frontier of interplanetary living, our responsibility towards ensuring the vitality and stability of Mars's biosphere becomes increasingly crucial. Holding the vision of a flourishing Mars that sustains itself and future generations, we see a beacon of hope, illustrating our ability to extend beyond Earth's boundaries and secure a foothold in the broader universe.